Okay. I ready to connect the streaming. We're live. Show us the screen, yo. Boom. Periodic functions. Let's see. Ah, perfect. Okay. What? Yeah. Okay. So, what are we going to do today? We're going to learn about periodic functions, but we're going to do it in a roundabout way. So, I'm going to give you a copy of this in just a moment, but we were just discussing how we've learned about certain functions this year, and you learned how to graph certain functions last year. So give me an example of a function that you guys can graph. Okay, I'm going to start with you, and I'm going to go through the table. An exponential function. Good one. That's like the toughest one out of all of them. So exponential function, what does it look like? Show me with your hands. Yeah, there you go. Okay, cool. You're next. What kind of function do you know how to graph? You said exponential. Cool. Okay, but give me an exact specific. Yeah, specific.
I was just saying that.
No, that's the word specific. Oh, the AVs. Yeah. What does A stand for? I'll pick another function. Come on, guy. Okay, we'll come back to you, Jim. A root function. Good. So what does that look like? Yeah. And if you were to describe it in words to somebody, they're like, I don't understand. What do you mean by that? What's a good way to describe a root function, how it looks? Anything else you want to say about it? That's pretty good. Finish it up, though. Half a parabola. Is it a sad parabola, a happy parabola? Or
A sad graph.
why is it? Because it went sideways. You know what I'm saying? It's kind of like Turbo. Turbo. You guys know Turbo from Wreck-It Ralph? Is it Turbo? Oh no, King. What's his name? King Cringe there. Wreck-It Ralph. You know there was Penelope. She was the glitch. But then there was the king there. What was his name? He was also called, King Candy, but he was also Turbo, wasn't he?
Yeah,
because he was like disguised. Yeah, so kind of like sideways, a little twitchy.
Then there was Felix.
Yeah, Fix It Felix. What a guy, man. Yeah, Fix It Felix with his girlfriend. You remember them all now? Okay, so we got root function, and he told us what it looks like. Go ahead. The quad. Yeah. What does it look? Oh, nice. What does it look like? What does the quad father look like? Ah, I do know. You do know. Yeah, you. Okay, and we got any more? What you got there, Chris? You just said that one. Man, keep up, guy. That's why you get 2 quick goals like that. All right, go after Zakuti. Go ahead, Zakuti. The what function? Cubic, good one. I like that. What does it look like? Yeah, stay alive, stay alive. You know what I'm talking about? Yeah. Okay, go ahead. Oh, good call. That one's going way back, right? That's kicking it old school, like grade 7. And are there any left? Did we take care of them all? Yeah, why is this side so smart and you guys are so... I'm not going to say it. Rhymes with plum. It starts with C. You guys are so crumb.
Oh. Whoa.
All right, so any others? Did we miss any? You're not even listening. Take your earbuds out, guy.
Reciprocal.
Reciprocal. Now, if you want to impress your friends, you might want to make your list a little longer. You know what I'm saying? Because then you run out after 6 or 7 functions. Y'all want to add one to it? Y'all want to go next level? Okay, Zakuti, show us what that curve looked like again. Okay, you see what he just did? Show us. Do the sparkler dance again. You know? Sparkler dance? Yeah. So, sparklers? You don't eat those. They're on fire, guy. They burn. Even after they're off, they burn. I know, because, you know. Anyway, so not all functions that look like this are cubic or polynomial functions. So today I'm going to give you 3 more functions that you could graph if you wanted to. And guess what also applies to all those 3 functions I'm about to show you today? Come on, guess it. Come on, the crumb side of the class. Yes? Boom! This guy knows. Yes. So, transformations. Yes? ABCD. You got the vert stretch. You got the Hor's comp. You got the TL or TD. Translation down. Oh, flexion. You flexing? Yeah. Why are you not in uniform, guy? You got all this red. What? Oh, it is. I forgot about that. I'm down. See? So, no matter how complicated it looks, remember, all those extra numbers are probably just your ABCDs. Alright? So, who wants to do this thing? Who wants to hand out the game? Jim, you got me? Jim, you got? Okay. And let's get you guys started. So, Jim, you taking left side or right side? Left side? Okay.
Oh, yeah.
Okay. Hold on. Don't go yet. The right side.
What was it, race?
Yeah.
Wait.
Kind of.
What's the
But
middle
you're not
line?
allowed to run. You gotta walk. You gotta speed walk. You're not a speed walk?
Yeah.
Wait, what's the middle line?
Let me show you.
Like,
You're allowed to. You gotta walk fast, but you can't go too fast. That's the. If you do this, you're running. You gotta
okay.
use hips.
So where's the border?
That's what we need to figure out. Let's establish the rules here. What do you want? Do you want it to be here or on the other side? Well, you can't be counting. Okay, this is the line.
Okay. I'll get left. I'll stick with that.
3, 2, go. Oh man. Oh, you guys are slow. Yo. Oh, he cheated. He's got a pocket back there. No, you missed Maya. You got one? Did he sabotage?
Finish line.
He's got his cycling hands there. He's got all the sticky from the blue bin. You know? Anyway, so you won? You lost?
Yeah.
So,
Listen, did you have fun?
I did actually.
Respect.
Good support.
Appreciate you. Yeah.
wait,
Listen.
I win! You forgot me.
Oh!
Yeah.
How deep does that cut, eh? Champion. Yo. Shows you celebration. No?
I don't celebrate.
Oh, sorry. You both lose. I'm the winner. Alright. How do you miss Radish?
You forgot, it's a time now.
Well, yeah, you both lose. You both tied for last place. The users. Okay, so let's talk MTV, shall we? Yeah? You want to do MTV? Before we do MTV, fill this in, okay? And there's a prize. Whoever gets finished first gets this, okay? No, it's the bag that my cookie was in, because it'll be done by the time you guys finish. You know, oily cookie bag. All right, do you guys understand what I'm asking you to do here? Don't you recognize? Look at this thing. What do you see?
Oh!
What do you see, guys? Well, yeah, the unit circle, but look inside. Okay? Stop being so shallow. Stop looking at appearances. Okay? You're all ugly on the outside, but inside, there's probably something good. Probably. What do you see inside the unit circle? Yo, check it. Watch. Oh, you my boy, Green.
No kidding. Talk about mine, man.
What's wrong with you guys? Is this daycare?
Taking my stuff, man.
What do you guys see? Which triangle? And Autumn, you got it? What's special about this triangle? It's a special triangle. What? Do you see it? Do you know the side lengths? Is this the 45 or the 60-30? 1 root 2, except we got to make a little adjustment. The little adjustment is if you go like this and you call this 1 and 1, that's root 2. Agreed? But that can't be root 2 because that's a unit circle. So let's back it up. What's that going to be? That's 1. You can call this x and you can call this
Y. X1.
what? What did you say?
X is the same.
You said that. All right. So, yes? So what's this going to be? How do you figure it out? There you go. PT. 1 squared equals x squared plus x squared. That's 2x squared is 1. How do you solve? There you go. This is PJ's. 1/2. And you know the plus minus. Can we ignore it in this case? Kind of. But you're right. No, when we put it on the unit circle, but so what do we have? We have 1, the square root of 1 over root 2. What's that the same as? The same as this, right? What could I replace square root of 1 with? Are you guys good? I find you guys cringy. Personally, yes? What do we call that? Taking the square root out of the denominator, yeah? Because right now, poco loco, right? Yeah. So let's unloco it. How do we do that? Oh, wow. Oh, there you go. You know how time sounds so sippy cup, right? So x ends up equalizing, that also sounds sippy cup, equalationizing root 2 over 2. So not bad. Cool. Now, do you see anything else on the inside of that circle? How many coordinates? So all of these brackets. All of those brackets are cats, but they're also coordinates. How many coordinates do you now know based on that little triangle right there? And don't say 1. How many? Jim, have you not learned anything? If I do this, that's not the answer, right? So, how many coordinates do y'all know? Who said 4? Oh, it's too bad because 4 was right. Do you guys understand why it's 4? It's always meow. Right? So y'all know that one, and y'all know that one, and y'all know that one there, and y'all know that one there. You know what this reminds me of? It reminds me of you ever go for Chinese food? And at the cash register, they got the cat doing this. Yeah, yeah, that's it. Anyway, why do we know all those four, and not just the one or two that you guys thought? Yes. Yeah, basically take that triangle and it's over here. Everything's going to be the same except what's going to be negative? Yes? X will be negative. Or if you were talking trig ratios, you would say cos would be negative. And nothing else is negative? Tan? There you go. Yeah. So do you know those coordinates? For sure. Same as that, except the x is negative. And down here and there. You understand what I'm saying? Pretty easy, right? So nice to see you. Don't be sorry. All right. So do y'all see the other stuff in that circle? Come on. Y'all see it? Stella, come on. Really? Which special triangle do you see? What type of triangle do you see? You know what? You don't know the name of it. Well, guess. Arthur, maybe? Gus? Penelope? Oh man, this is such a high quality board that it moves when I write on it. Is that the triangle that you're imaginationizing? What'd you call it? Yeah, that looks like an equilateral. It's like you look like a Stella. What's the side length? How did you know it was one? Unit circle. Radius is? There you go. So, do we know the coordinates of that? Well, I don't know. But could we find it? Yeah! You see the angle? What's the angle down there? Yes, Jaheem, are you with us? And Instagram at the same time? On your calendar. It's the 5th today. There you go. So, do we know the coordinates? If that's 1, that wasn't what it was before. Y'all remember what it was before? No. What was this before? We made it simple. 2? Why did we make it root 2 or 2? Why did we make that 2? Yeah! So then when we cut it in half, we get a nice number there. Right? We could have made it 1. And what would have happened to that number? If we make this 1? Yeah, so divide that by 2, divide that by 2. Now somebody was telling me what this one was before. What was it? Okay, well when I divided that one by 2 and that one by 2, yeah. You know what I'm saying? So that triangle right there fits on our unit circle. Boom. How many other coordinates do you know now? What do you think? Matthew? 3? No? 4? You guys agree? 8. You're right. But eight is a better answer. Who can tell me why 8 is a better answer? Yes? Yes. What does he mean by that? Do you guys see the other triangle?
That.
Yeah. Whoop, whoop, whoop. Okay, somebody tell me the coordinates of this dude. Chris, go ahead.
Top one is 1/2, 1/2, and then √3/2.
Huh? You guys get that? Somebody give me the coordinates of this dude. Tierney? Oh, he said that. What do you mean the other way? So the x of one is the y of the other? Whoa. That's crazy. So do you see what I mean by you knew the 8? You actually knew the extra 8. Right on. So we'll finish that thing up and let's get busy. Y'all ready? You done? Yeah, getting jiggy with it. Na 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 na. Na 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 na. That's a good song. Oh, this cookie's pretty good. It's too bad nobody won my empty bag. It's not empty anyway. So you guys were all dressed up yesterday? Yeah, I didn't even see you guys. I didn't see you. I'm sure you were. I just didn't see you.
He won third.
What'd you win?
Oh.
Oh, because you're so majestic. Right on. Your Majesty. Did you win one? But boy won one. What did he win?
Why not this?
No, your boy. Here.
Oh, yeah. I don't know what he was. You know,
He did win one. I heard his name. And I'm like,
teacher's
"Oh."
pet. That's what he was.
Okay. I must have voted for that one. You guys done?
Yeah.
He wasn't there, no. I asked him this morning, and because I told him he won one, and he asked me what it was. I said, I don't know. Okay, so what are we going to do with our unit circle? We're going to find out what these three functions look like. Here comes the reveal. Today, we're going to graph this function here. Does anyone want to guess what the first function is going to be called? What type of function? Nobody wants to guess? We already know how to graph that. A good guess. What? Sinusoidal. Yes. We're going to learn how to graph this. You could write it this way as well. I just don't want you to be to get confused. But here's another way. This would be using function notation. But what you might find confusing is the x and the y. So I'm going to use theta instead. F of theta, sine of theta. And what's the first method you learned to use in order to graph something back in grade 6 or 7? Yeah? So we're going to do a TV, not an MTV. We're going to use a few more points than and what I'm going to do is if you check on the workspace, This is what I had for y'all for 6.1. Trig function intro assignment. I give you this table and I ask you to complete it. Look at the values. Now these are just Greek letters, right? Do you guys know what this Greek letter is? Alpha. Was this one over here? Bravo, Charlie, Delta, Beta. It is Beta. And this one's over here? Okay, so we got Alpha, Beta, and Theta. There's no particular significance. You could use any Greek letter you want, or you could use any letter, English letter you want, or French. It'll be the same, French and English, without the accents. So look at these numbers. What do you notice? 0, 45, 90, 135, 180. They're multiples of 45 degrees. Do you need your calculator to calculate the sine of any of those angles? No? Why not? Why don't you need the calculator? Yeah. What about it? Yeah. So you already know what the sine of 45 degrees is, which means you know what the sine of any multiple of 45 degrees is. And you might say, well, what about 90 degrees, which is... The reason you know that one is because if you look at the unit circle, what's the number there? What's the x value of this point? 0, and there? 1. So you're going to use 0 and 1 and radius of 1 to find sine and cosine. We good? So let's do our table of values. Let's fill this in together. And where was that? Right here. Maybe I'll take a picture of that so that Sam can see me writing on the screen when he watches the video, and whoever else is missing can do the same. Okay, we're about to take a picture of this right here. Let me scroll down. All right. Hey, I'm supposed to take a picture. Oh, yo. Send. Full send. Thank you. All right. What do y'all think? What's sine of 0? Anybody remember how you calculate sine? You could go SOHCAHTOA, but probably easier if you just use x, y, and r. You know what I'm saying? So sine is? Try again. Sine is y over r. Young and the Restless. Okay, well, look at the point for 0 degrees on the unit circle. Where's the 0 degrees at? 1, 0. Everybody agree? So what's y over r if your x is 1 and your y is 0? Exactly. So the answer would be 0. Let me activate the pencil or pen. What color are we using today, y'all? You're my boy, red. Yeah, it's red day anyway. So red is rad. 0. It's 0. Actually 0 over 1, but it's 0. Y'all understand? And we know this because sine is y over r. The unit circle, r is 1. And then whatever y value is in your coordinate. Well, what's the y coordinate at 45 degrees? And let's go to Reese. What's the y coordinate at 45 degrees? unit circle? The y coordinate. Y'all agree? Come on, show them some love if you agree.
Yes.
Yes? Okay, I agree. So what's our answer? Yes, because the y is root 2 over 2 and the x is 1. Pretty easy. All right, next one. Isaac, at 90 degrees, what's the y value? And what's the r value again? The radius of the circle is? Yeah, so you got 1 over 1. Boom. How easy is this? All right, take 30 seconds, maybe 20. Fill out the rest of the table right now. Do it. What's up? You serious? Guy, 45 degrees. See the triangle? We need the y value of that point. Where's that unit circle you got? Did you fill any of the points in? We'll fill them in. This guy, he doesn't play. This is cool. He even went and pen, he was so confident. I don't need to erase any of this. Get it right. Now,
He knew it.
you all should have had this labeled by now, but I guess I need to spell it out. Are you guys missing any numbers? Okay, you know what? Before you go on, fill this in. And you shouldn't need to copy off of somebody, because the numbers are all right here on the board for you. You understand? That's this number here is the x coordinate of that point right there. This number here is the y coordinate. Because if this is 0, 0, that's the origin juice.
The origin.
Yeah. So if whatever you go right, that becomes your x coordinate. Whatever you go up, that becomes your y coordinate. Yes? This also is the origin juice. Yeah. That makes me want to drink some origin juice. Not kidding. Yeah. Shake, 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 Tropicana. Shake it Many people have told me that. Eight days.
It took 11 days.
Yeah, nobody see a day. Okay, that is fifth grade.
Way longer than that. Actually, no, it's not.
Guy, why are you copying? You don't need to copy. It's all on the board, man.
It's a reference.
Look. Look. This is 45 degrees. Oh, you got that. So those numbers go there. Except the x will be negative. You know what I'm saying? Then those numbers go there. And then x and y are negative. By the way, I'll help you label the other thing as well. The other part of that right there. Unit circle. Activate. Copy. Paste. Enhance. Paste. Enhance. All right. So, children, here's something that you may not have considered. you can label all of the coordinates for the points, but maybe you're wondering, what are these blanks her and her for? Well, they're both measurements of angles, but in different units. Can anyone tell me what I should write there? Right there. Yes? 30 what? Yeah, good job. So that should be 30. So how do you know? Well, because the degree symbol's already there. That one's 30. This one's 45. This one over here is 60. You know what I'm saying? And then this one, her, would be 2 of these. You get it? 2 slices of pizza. Not square pizza, though. So 120. Oh, I don't know, man. I bought some Costco deep dish last week. First time it's I think a new product. It's pretty awesome. It's double pepperoni deep dish at Costco, and I'm telling you, I don't like frozen pizza usually. This one, next level. Yeah. It was delicious, and this was very close. That's what I'm saying. It's not like the Mike's there and the other ones that they have. Right? You guys know the pizza I'm talking about? The Mike's Supremo or whatever it's called. Anyway, you guys can label all those degrees ones. You understand? What do you think the other blank is for? This guy's rad. He knows. I know. Okay, children. Does anyone remember how rad this was? This angle right here. How rad is it? It's pretty rad. Something that's rad is worth about 1 pi. Yeah. What would be better than 1 pi? That's really rad. Yeah. So what I have right there is 1 pi. Rad. So pi would go right there. You understand? Well, what would go up? Her. Here we go. And if I cut the slices again in half, what's that going to be, Jim? Right there. Boom. And then if I divide them again, right here. Oh, he didn't fall for it. Because what I did is I didn't divide my pi over 4 by 2. I took this, or I took this. I take this and I divide it into 6 equal slices. 1, 2, 3, 4, 5, 6 slices. You understand what I'm saying? So that's why this her is pi over 6. Y'all get it? That's pi over 6. Pi over 6. What will this one over her be? Meow. Isn't it the second slice? So what would you call that angle? Yeah. Yeah. The first one was pi over 6. How many pi over 6s now? No. You got 1 pi over 6. If 2 pi over 6. Y'all get that? But there's a better answer. Who knows the better answer to 2 pi over 6? No, you don't know. Anybody else? Dustin, what do you think? Well, who's right? What? Well, you're just stealing his answer now. Good job, Dustin. Yes, you were right, but you stole it. So you're right, pi over 3. You get it? Yes, it is plagiarism. Well, here's a tough one for you. If this is 1 pi over 6, and this is 2 pi over 6, what's this one her? Matthew, seriously? 1 pi over 6, 2 pi over 6, 3 pi over 6. Exactly, right? But you knew that that could be reduced to? Boom. All right? Y'all down with that? So if I erase all that writing, clearing for page, we got pi over 6, pi over 4. This one is 2 pi over 6, and this one is 3 pi over 6, and this one is 4 pi over 6, and this one is not 5 pi over 6. 5 pi over 6 is there. And this is 6 pi over 6. Whoops. My pi's up top. Do you see that? 1, 2, 3, 4, 5, 6. But when you can reduce it, you do. And this one is reducible to pi over 3. This one is reducible to pi over 2. Is that one reducible? Yeah. And then how about this one here? Nuh-uh. And this one here? What? 6 pi over 6? Well, then the answer would be yeah, not nuh-uh. Right? What's up? I said that. I circled the ones you could reduce. I squared up on the ones you can't reduce. And then Matthew tried to square up, and then he found out. He found out. Right? Yeah. Not your first, but probably your last, right? For those of you watching the video, that's just Argent juice. You gotta keep it real. Okay, so you guys know how to label the rest of it, right? Reduce the ones you can. And you're probably wondering why aren't the pi over 4s getting any love? So let me clear the ink. Where's the clear the ink part? Edit. Clear ink. So here's the pi over 4 right there. That's this one. So that's 1 pi over 4. Who can tell me what this one here is? This guy with his pi over 2s. You're not wrong. You're just wrong. What am I looking for, Matthew? Thank you. 2 pi over 4, which, yes, it might reduce, but we're just counting right now. 1 pi over 4, 2 pi over 4, what's that one there? 3 pi over 4. What's this one? Oh, that's a 4. What's this one over here? Don't say just. 4 pi over 4, and so on. You know what I'm saying? 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. And then reduce the ones that you can. Can you reduce this one here? Can you reduce this one there? And her? Get it? So when you can reduce, reduce. Aight. We're getting rad with it. So now that your unit circle's all labeled, and try to keep up, hey Cole, tell them. Let them know. Yeah, try to keep up. Cole, is your table done? Your TOV? No, your table of values. I mean. Yeah, no, I hear what you're saying. Okay, so turn that sheet over, guys. And we're going to make a graph, but you need to write this table somewhere, okay? And you need to fill it out. You can use the letter alpha, you can use beta, delta, whatever you want. Make sure it's Greek, otherwise it'll be wrong. What's that? Green. Green like the Benjamins. Excellent question. I'll tell you that in a minute. Do your table. And since you're talking about the green, we should listen to a little J-Lo. Yeah, y'all know about J-Lo? Let's find J-Lo, yeah. What's that? That was the last song in the dance? Oh, yeah. Oh, that's right. It was so good. Did you dance, Jim? You didn't even show up, did you? Yeah. It's okay. That's not the song I was looking for. That's the one. J-Lo, Mr. Worldwide, no DJ Khaled. More money. Do you guys know what that means? No, yo quiero dinero. I want the money. Yo quiero means I want. Dinero? Money. Give me the money, yo. Keep the green on board. Okay, y'all finish this table? Why does it take so long to do this table? It's either 0, you don't have to draw it. I just want you to fill in the numbers. Your answers are either 0, 1, -0, -1, or root 2 over 2, or negative root 2 over 2. That's all those numbers are the same number, and they repeat. You know what I'm saying? Well, this is sine, right? So sine is supposed to be y over the r coordinate. Use your unit circle and use the y values that are in your coordinates for the 45ers or the pi over 4s. What'd you guys lose? Oh no. Yeah, I'm wondering where my I had 2 sweet Stadler erasers made in Germany, you know, the expensive ones, and they're gone. Guess who borrowed those? Somebody in this class. So now I'm using this trashy Dixon, probably made in Taiwan. Yeah, probably. Mr. Steak. Okay, Jaheim, are you done? Let's go, guy. Step your game up. For 45 degrees, should be root 2 over 2. What's 135 going to be? Exactly the same thing. Well, because what's the y coordinate at 135? Look at your circle if you want. Over 2. Okay, so then root 2 over 2 divided by 1. That's your sine, right? Sine is y over r. Y value over the radius. It's a unit circle. The radius is 1 everywhere. We're down? Now, Matthew, what's it going to be at 225? What do you mean by the same thing? What quadrant is 225 in? Well, just look at your circle. It's past 180. Yeah? No. Yeah. What's the y value? You have to be in that quadrant. So what'd you say? Oh, I thought that's what you said. Okay, so you see how quick this should be? Check it. What's the y coordinate at 0 degrees? 0 over 1. What's the y coordinate at 45? Root 2 over 2. What's the y coordinate? Shh, ladies. What's the y coordinate at 90 degrees? 1 over 1. What's the y coordinate at 135, Radish? Root 2 over 2 divided by 1, so it doesn't change. What's the y coordinate at 180? Negative 1. Whoop. Y coordinate. Try again. Y coordinate, not the x coordinate. The y value. The y value tells you how high you went up. You're on the x-axis there at 1. So the y coordinate is 0. So that means sine is 0, right? Y'all go down? Holly, you got the 225er? What's the y coordinate at 225? Nice. L, 270. Yeah. What's the y coordinate? Bro, look at your circle. 270. What? It is. Rhea, you guys good? What are you figuring out here? All right, and Mahat, what's the 315? The y coordinate for 315? What? Oh man, what's going on, guys? This isn't really complicated, is it? 315 is right here. What's the y coordinate? What do you got? Macaron. What? Oh, that was close. Negative root 2 over 2. And at 360? And guess what happens if I keep adding 45s to this? It's the same pattern that's going to repeat. You understand what I'm saying? Yes? Y'all want to graph this and figure out what it looks like? That's what I put that graph paper on the back for. So let's checking it. I guess I better take a picture of that so I can throw it on her. Actually, I can just copy and paste it. I've got it. Yo quiero dinero. Me and Benjamin Franco. Banco. Money. Yo quiero dinero. Okay, we had a good question. This guy over here asked me, how do you know where root 2 over 2 is? How would you guys figure that out? Come on. When you're trying to add 3 and 4, what do you guys go to usually? What? Exactly. Because you're weak. You hit the calculator. Well, hit the calculator right now. What's root 2 over 2? Nobody wants to use your calculator. Okay, who's got it? Wow, does it really take that long? Are you asking ChatGPT? You should just go to your calculator, man. 0. What? Okay, so let's just round it to 0.71. Y'all down? But here's the nice thing. Forget about it. Why? Because this. Go to the... We're just going to highlight the dudes that we find really important. 0, 90, 180, 270, 360. Okay? We're gonna highlight those guys. We're gonna plot those right now, and then we'll come back after and see what's up. So this is actually your angle. So we're using alpha. So we're gonna change that x to an alpha. And this over here is f at alpha, not y. Well, not x either. So it's f at alpha. Just remember that. We down? So what's the alpha coordinate? The first one I circled was 0. And what was the f at alpha coordinate? 0, 0. So that's easy. Delicious. Delicious glass of Argent juice. Okay, what's the next highlight? 90 and 1. So I go to 90 and I go up to 1. Y'all down? What's the next highlight reel? 180 and boom. Next. And right on. And next. And boom. Okay. Everybody got this? Well, we haven't connected the dots. Shall we connect the dots? All right, check this. Whoop, whoop, whoop. Oh, let me try that again. Whoop, whoop, whoop. When you're done copying this, take your eraser and erase it. Why? Because where's Charday at? Hold on. And this is actually a very important lesson for y'all to learn. The lesson is that today's music is trash, and you got to kick it with the old school. Hold on. It's a 12-second ad for Tic Tacs. 12-second ad. Smooth sounds. Check it. Okay, listen up. Listen. Oh, of course it's the bridge. Hold on. There it is. Smooth operator. Smooth. This guy's getting a swerve on. Respect. You hear that? That, what we did right there, not smooth. That's jerky. Okay? So, we need to fix this. How can we fix it? Remember the numbers we calculated earlier? The 1? What was it? 0.71, right? Guess how many times we're going to see 0.71 if we go up to our TOV. Where's our TOV at? Well, on this one, how many times are you going to see 0.71? 4? You're close. The answer is 2. Well, how did I get you guys? Because kind of it is 4, but I didn't write it, but how do you see it 4 times there? 2 is correct, but 4 is also kind of correct. Yes, Maya? 2 of them are going to be negative. So this is going to be 0.71. This is going to be 0.71. This is going to be 0.71, except these ones are the negative versions. So if I estimate 0.71 on my graph, which is on this page right here, and remember I'm at 45 degrees, 0.71 should be a little higher than that. You know what I'm saying? And 0.71 should be a little higher than that, and a little lower than that, and a little lower than that. Right? But I don't need you to plot those points. you can go highlights and then just go smooth operator. So smooth operator means don't connect the dots directly. You gotta, whoa, what happened there? Yo, I want to get rid of that. Okay, so I guess I'll just clear the ink and do it again. So 0 and 180 was 1, 270 was 0. No, I messed that up. Sorry. Okay, 0 was 0, 90 was 1, 180 was 0, 270 was -1, 360 was 0. Y'all down? All right, and then in your brain, press play. And as you're listening to those tunes, getting your swerve on, connect the dots. Smooth, do it again. Smooth. To Chicago. And if you're not done getting your swerve on, then go on the negative side. Because guess what happens? If we go -45, -90, -180, -225, negative all that stuff, the highlights repeat. So somebody guess where we're going to be at for -90. What's the Y value going to be for -90? -1. And you might be wondering, how would you know that? Look at the unit circle. And y'all remember what it looks like when you go -90 degrees? This is 0. Negative has to be in this direction. Positive is going in this direction. If I go -90, it's the same as going positive 270. What was 270? -1. Y'all down? So what's my next highlight point? 180, -180, sorry. What do you got, Reese? Coming to Isaac after that? Reese, -180? Back to 0. And then Isaac, -270. Close. +1, good. And Radish, -360. Back to 0. And then you press play. You're not giving me an ad, are you? There we go. Smooth operator. Smooth operator. Oh, yeah. Silky smooth. All right. And now, if I ask you, what does the sine function look like? You can do, you know how to do it? You can do that, or, there you go. Yeah. Oh, no, don't get jerky. Don't do the jerky. We're not doing the robot. We're doing the, yeah, there you go. Smooth out. It looks like a way. Oh, there we go. Skills. People usually do it this way. People usually go this, and then they start the wave, and then it comes in. You got to go out with it. Oh, that's different, though. You should just go one way, like down, and send it back up. You know what I'm saying? There you go. Yeah. Send it up. Yeah. Don't do this. Don't do. Wait. I just sent it both like that. But then you could. I mean, you could. But you're trying to send it to somebody, right? It's like it starts over here. Give it to you. Boom. Yeah. Send the cheese touch, yo. All right. Anyway, okay. So we just learned how to graph sine. You think graphing cos is going to be easy too? Straight up is going to be easy. So this right here is, sorry, not y equals. We use function notation. So f at alpha equals sine of alpha. No, you get to choose whatever letter, Greek or not. Okay, so you start with your wrist and your hand, okay? So you're gonna hinge, and then you gotta let the elbow come up. So elbow comes up, shoulder stays down, then the arm goes down, and then it's coming through. Okay? Then you pop it. But you're not really pop. You can pop, but we're trying to do waves, so you're trying to be smooth about it. Get smooth with it. Try it. Yeah? Yeah, but just hold your arm up like this. Okay? And then just send it. Like the rubber pencil. There you go. Yeah, you got it. Yeah. Boom. And then there you go. Yeah. Don't be afraid to let your elbow come up. Don't be afraid to let the elbow come up. See? Elbow comes up. There you go. Yeah. You follow through with it. Follow through with it. Let your hand go down. You know what I'm saying? Yeah. There you go. Yeah. You got it. Keep going down. Let your shoulder come up. Yeah. Good. There it is. Oh, this guy's got it. Oh! Respect. This guy's got it locked down. Yeah. Matty the B-boy. Yeah. What's that? I wouldn't say pro, but I'd say semi-pro. At least semi-pro. Okay. So now that we know how to graph sine, y'all probably want to graph cos, don't you? Good, because we're going to graph tan instead. Because tan is challenge. This weekend, you're going to do this whole operation, but you're going to do it for cos. You might be like, well, how am I ever going to do that? Well, first thing, you're going to go to the workspace. And look, I use the letter beta, and G of beta is cos beta. So we're going to see what the cos curve looks like. Newsflash, it's pretty easy. But you're going to use these angles, do your thing. The highlight points are still going to be the most important points. Hey, make sure you hit play on smooth operator before you connect the dots, okay? Let's move to tan. Now, for tan, here's what we're going to do for tan. We're going to I'll highlight the ones that I want you to use. Excuse me. What's going on now? All right, let's send it and check it. So I want you guys to look at your unit circle, and here's what I'm highlighting. 0, 45, and multiples of 45. So you know what comes after 45, right? 0, 45, 90, 135, 180, 225, and so on and so forth. Okay, how do we calculate tan again? Tan is y over. Okay, so if tan is y over x, look at your unit circle. At 0 degrees is what's the y value? At 0 degrees, what's your y value? What's your x value? So we have 0 over 1, which is essentially 0. Okay, at 45 degrees, what's your y value? Ooh, that's ugly. And what's your x value? Equally ugly. And what do you get when you divide ugly by ugly? No, you get 1. It's so pretty, right? So root 2 over 2 divided by root 2 over 2 is 1. Nice. Go to 90 now. What's the y value at 90? The y value at 90 is 1, and the x value is? Rhea, pay attention. I'm tired of hearing you guys talk. Okay, the y value is 1, the x value is 0. What do you get when you divide 1 by 0? Your calculator is going to explode. Do not punch that into your calculator. Why? You get an error because it's a math error. It's undefined. You cannot divide something by 0. So we call that undefined, and in your sippy cup language, that would be called a lava line. So grow up and call it what it is. What's it called? An asymptote. What kind of asymptote is it? Say again? It's a vertical asymptote. So at 90 degrees, you're going to get a vertical asymptote. 135. What's your y value for 135? Ugly. And what's your x value? What's your x value at 135? Look at the circle. No, it's not. Negative ugly. What do you get when you divide ugly by negative ugly? Negative 1.
Positive is beautiful.
Okay. So I want you to try and graph both of those this weekend, okay?
Positive is beautiful.
Take care. Please leave.
Oh, y'all gotta bring this back.
It's
the same thing. It's goodness.
It's